All right, guys. So today I want to talk about how to balance a chemical equation. So this is probably one of the first challenges you're going to meet when you go into chemistry. And then I know people, there are all kinds of tutors, all kinds of professors say, "Oh, this is the way to do it. Lots of methods, right?" And they're confusing when you follow steps, you miss a step, and then you got lost. So I just want to show you what is my way, what is my way of doing it, and why I found it is really the simplest. So the rule is simple, all right? So you go from left, so you start from left and you go to the right. So by left and right, I mean the left hand side and the right hand side. And then you go back to the left and you go back to the right. And I'm gonna show you what I mean by this. Let's do quite a few examples, all right? So let's do the simplest. So you have carbon, you have oxygen, and you're going to produce CO. Sorry, this should be numbers. So you're going to produce carbon monoxide. So how should you balance this, right? Um, well, it's always going to be like this. You're going to be provided the chemicals, that's going to be the reactants and the products. So you start from the left. So you see what you have on the left. You have carbon, you have oxygen, and on the right, you also have carbon oxygen. And how many carbon on the left do you have? Well, right now, just mark it right now here. You have one carbon. And how many carbon do you have on the right? You also have one, right? And at the same time, how many oxygen do you have? You have one. But at the same time, if you go back to the left, well, you actually have two oxygen over here, right? You have two here. Well, if you bring the two over here, that means you are going to at least need two carbon monoxide to match the O2, right? Because over here, the O2 is going to break into an oxygen and another oxygen. And if this one's going to make into a CO, and this one's going to make a CO, the two of them makes two CO, right? So you're going to have at least two CO here. And then that's when you move to the right, you bring this 2C back to the left. So, well, because right now the oxygen already matches. So what about carbon? Well, carbon, now you have two carbon here, but you have one here. So you time this by two. So that's why all you have to do for this one uh, is you're going to put a 2 as your coefficient in front of the carbon and the CO. Let's see another example here. So what if you have your CO starting from here plus another oxygen to produce carbon dioxide? All right, so it's getting a little bit complicated. So let's start from the left. So what about carbon? So carbon, you have one on the side, and you also have one on the side. So it's matched. What about oxygen here? So for oxygen, you have two oxygen here, right? So it's O2, so it breaks into two oxygens. But on the left-hand side, you actually have two oxygen already from just O2 and another O here. So that's not going to be a match. So what should you do in this case? Well, let's first multiply the CO by 2. Why? Because if you're going to need more oxygen, is it easier to multiply this or multiply this? Well, intuitively, it's gonna be the oxygen, right? Because it only provides oxygen. If you need oxygen, you only give it oxygen. But in this case, if you bring oxygen, you actually bring in carbon, so that makes it just a calculation disaster. So let's just multiply this by 2 at this time. So that's gonna make it 2CO. So if it's 2CO, right? So how many carbon do you have here? You're gonna also have two carbon here. So it's 2CO on the left hand side and 2CO on the right hand side. So now how many oxygen do you have? Well, you have 2 times O2, so that's 4 oxygens. And how many oxygen do you get from here? You get 2, right? So you're gonna need 1 O2 from here. So if we clean this up, you get this, and it's balanced, right? So how do you double proof check? You just add up all the atoms you have on left hand side and right hand side, right? Just to proof check. How many carbons do you have? You have 2 on the left side. How many on the right? You have 2 on the left hand side, right hand side. What about oxygen? Well, you get 2 oxygen from here, from the CO, and you get another 2 oxygen from the O2. So that's 4 oxygen. And on the right hand side, you also get 4 oxygens because from the 2 of the O2, right? So it's a match. So let's move to the next one. And then these are a little easier. So let's make it complicated. So what if you have so this is something you probably see a lot, like acid-base reaction going forward plus H2O, right? So now you have how many kind of type of atoms do you have? You have K, you have O, you have H, and you have P, right? So you have 4 kinds. And now you're gonna balance it. What's the easy way to do this? Well, in this case, my suggestion is you have to know how it works, right? So if you just simply start counting, it will get very complicated. So the way this works is because it's acid base, right? So we're gonna know that it's gonna start from OH plus a hydrogen going to H2O. So that's how this thing works, right? So I will focus on, and this is how, so because this is the most important part, if you balance this out, the counterpart will automatically just balance out on its own. So let's just focus on the OH and the H for now. So how many OH do you have? So you have so the O4, the PO4 and the PO4 always go together. So there's no need to be concerned about the O4. So we're only concerned about how this O is going to become the O in the H2O. And we notice that um, over here, you're going to actually get, if you have one PO4, you're going to get 3 hydrogens, right? But at the same time, you only need one hydrogen to pair with the OH to make it into H2O. So what does that mean? So that means you're gonna need at least 3 H2O in the product to match the H3 in the H3PO4, right? And at the same time, if you have 3 H2O on the right side, you're also going to need 3 OH on the left side. Well, now you have 3 OH, you also get 3K, right? And what about the 3K? Well, the right hand side, you also have 3K here. So that's going to tell you something. That means you're probably on the right track. You have K3, then you have one PO4, which you also have one PO4 over here. So that's how it's going to be a balance. So basically, dear, like if you go so strict with a rule from the textbook, many of the times I find students confused, and then usually it's not going too well. So sometimes, like don't panic. Some equation can be very complicated, but most of them it's only going to take you a minute. So just take your time, make sure you're doing the right thing. All right. So let's do another example because um, this should be and like honestly, just get more practice. Like before exam, I'm pretty sure if you do 20 of them, you'll get it. 20 of them, that's enough. All right. So probably go to the back of your textbook and then see for yourself. All right, so what about this one? So if you have NaHCO3 and then you're gonna make it into NH2CO3 plus H2O plus CO2. All right, so now you have one molecule on the left side, but you have 3 molecules on the right hand side. So it's called decomposition, right? So how should we approach this? Well, so this NaHCO3. Yep. So let's first consider the Na part. So because this is over here is Na2, right? But over here is Na. So that means you probably at least going to need 2 NaHCO3 just to match the Na part. All right, so if it's 2 now, what do you have for the rest of them? So you got 2 H's and 2 CO3. And then, but at the same time, you're actually only gonna give one CO3 to here. So that means you're gonna be left with one CO3. And coincidentally, so now you have 2H and 1 carbon and 3 oxygen. So what about the rest of this? So HCO, you have 2 hydrogen, 1 oxygen. And over here you have 1 oxygen and 1 carbon and 2 oxygen. So the 2 oxygen and 1 oxygen give you 3 oxygen, and it's a perfect match. So that's why um, that's why we can know that because of all the molecules, all the atoms are matching up. This will be a simple one just by timing this by 2. So you see, basically you have to start from somewhere. When you get this problem, you see, oh, there's Na, there's H, there's, oh, which one should I go with? Well, however you're going to go with, just start from somewhere and then just dive in with it, right? So why did I pick the Na? Well, because there is a very clear uh, relationship between here because there's Na is only showing up on the left hand side once and showing up on the right hand side once. Why did I not pick the oxygen in this case? Because oxygen is showing up once in over here. It's also showing up in every one of them. So it will be very hard for you to determine how many of them exactly do you need if you start with oxygen. So I will pick the one that's most unique in each side of the equation. And I hope this will be helpful to you. See you in the next one.